All right, let's give this a shot. So I'm going to go over number one here. The fastest helicopter, the Westland Lynx, can travel 3.33 kilometers in the forward direction. Okay, so we're just going to refer to that as the positive direction in just 30 seconds. What is the average velocity of this helicopter? Express your answer in both meters per second and kilometers per hour. Now, we're dealing with average velocity here. So, well, yes. First thing I want to do here, and with any calculation problem that you do, you want to make sure you do this step, which does take some time, but you will be amazed at how much utility you get out of writing down what you know is being given from the prompt. You know that the delta x is going to be 3.33 kilometers in the forward direction. So my delta x is going to be 3.33 kilometers in the forward direction. And that happens in 30 seconds. So my delta t is going to be 30 seconds. A quick question, does time need a direction? No, because it only goes forward, right? So we do not need to include that. Now, velocity average is equal to delta x over delta t. Now, I always use the example because this is what pops in my head. I actually think about this when I'm doing these problems. When you drive down the freeway, there's a speed limit sign, right? Out here on I-5, it's 70 miles per hour, okay? 70 miles would be a delta x in 1 hour, which would be a delta t. Now, that is a speed limit sign out there because does that limit sign tell you what direction to go in? No. Now, if you want to get like pedantic, you'd be like, you can only go one direction on the interstate. Fair. Okay, fine. But in terms of that sign, it's a speed limit sign, and you notice it just says 70 miles per hour. Okay. So I'm going to use this. I'm going to extend that. So again, my delta x, which I have written down over here, 3.33 kilometers over 30 seconds. Now, this is going to give me an answer, and it's going to have the units of kilometers per second. But what is the question asking me for? Kilometers per hour. So what I'm going to have to do is I'm going to have to include something that is going to cancel out of seconds and into hours. So there are 3,600 seconds in 1 hour, if you guys don't remember. And so seconds is going to cancel. And my final answer here is going to be in terms of kilometers per hour, and this is going to be 4.00 times 10 to the second, good handwriting, kilometers per hour forward. .00 times 10 to the second power kilometers per hour forward. So that's 400 kilometers per hour. Fair enough? Now I also have to do meters per second. So I'm going to set this whole shebang up one more time. But instead of this kilometer here, I'm going to use meters. And then I'll keep seconds the same. And this will end up being 111 meters per second forward. So these are the same velocities, just using different units. Okay? Any questions on number 1? Question. You're talking about right here? Because the question is also asking me for a meters per second, right? So here, I needed to turn the kilometers, which was given to me by the question, into meters. So kilo is 1,000, right? So it stands into a third. Fair enough? Andres, you had a question? Say it again? Okay, I'll take a look at that in a minute. But other than that, we feeling good?